created by MindSticks Foundation Trust.
Hello, and welcome students to today's Explainer. Today, we're going to master simultaneous linear equations. Our agenda is quite straightforward. First, we will look at determinants and Cramer's rule. Second, we'll learn how to reduce nonlinear equations. Third, we'll explore some real-world applications. And finally, we will wrap up with our core mathematical takeaway. Section 1. Determinants and Cramer's rule. So, let's start with Cramer's rule. What is absolutely brilliant about this method is that it gives us a highly structured, almost puzzle-like way to find the exact values of x and y. Instead of guessing or endless substitution, we just arrange our numbers into a neat little grid, which we call a determinant. By calculating three specific values, known as d, dx, and dy, we literally unlock the solution. It's incredibly systematic, and honestly, once you spot the pattern, it's actually really fun to solve. Let's dive right into this example. If you check out the equations we have, we first need to find our main determinant, d. We do this by taking the coefficients of x and y and placing them straight into vertical bars. Now watch the cross multiplication. We multiply 5 by 4, which gives us 20, and then we subtract the product of 2 and 3, which is 6. So 20 minus 6 gives us 14. And there we go. That is our d. We just repeat this exact same pattern, swapping in our constant numbers, to find dx, which comes out to negative 14, and dy, which is negative 28. Finally, the real magic happens. To find x, we just divide dx by d. Negative 14 divided by 14 is negative 1. And y is simply dy divided by d, giving us negative 2. It is beautifully methodical, isn't it? Section 2. Reducing nonlinear equations. Now, what happens when equations try to trick us? Take a moment to observe these equations. You'll notice the variables x and y are sitting right down there in the denominator. For instance, 3 upon x minus 4 upon y equals 8. Because these variables are in the denominator, their highest degree is not exactly 1. So they are not actually linear equations right off the bat. We definitely cannot use Cramer's rule on these just yet. We need a clever little strategy first. To outsmart these tricky problems, we can rely on a very simple 4-step method. First, we identify that nonlinear fraction. Second, we temporarily swap out those complicated fractions for simple, friendly variables, maybe something like m and n. Third, we just solve this newly formed linear equation using the exact methods we already know. And fourth, and please remember this is the most important part, we resubstitute to find our original x and y. Let's follow along carefully with this one. We have the equation 4 upon x plus 5 upon y equals 7. It certainly looks intimidating, but notice how we can rewrite it as 4 multiplied by the bracket 1 upon x plus 5 multiplied by the bracket 1 upon y equals 7. Now for our magic trick. We simply replace the 1 upon x with m and the 1 upon y with n. Immediately, our complex problem transforms into 4m plus 5n equals 7. Look at that, a completely familiar linear equation. We then solve for m and n, finding that m equals 3 and n equals negative 1. But remember our crucial step 4? Resubstitute. Since m is 1 upon x, that means 1 upon x equals 3, which makes x equal to 1 upon 3. We have successfully unmasked the final answer. Section 3. Real-world applications. Now, I want to pose an important question to all of you. How do we actually use simultaneous equations outside the classroom? It is so easy to think of x and y as just random letters on a chalkboard, but the truth is, abstract algebra is actually the ultimate key to solving everyday mysteries, from calculating your business costs to figuring out tricky measurements. This perfectly illustrates how plain English sentences translate beautifully into mathematics. Let's look at this logic flow. It says, the sum of present ages of Sarthak and Sakshi is 25. Well, if Sarthak is x and Sakshi is y, that simple sentence literally becomes x plus y equals 25. Easy, right? Now, consider another example regarding a rectangle. The perimeter of a rectangle is 40 centimeters. We all know the standard formula for a perimeter is twice the length plus twice the breadth. So, we frame it as 2 times the bracket x plus y equals 40, which easily simplifies down to x plus y equals 20. By just carefully reading the word problem, we extract the simultaneous equations hidden right there within the text. Let's walk through this fantastic real-world example of a wristwatch discount sale. This is exactly the kind of thing a shopkeeper might face. On the very first day of the sale, the shop sells 11 analog watches and 6 digital watches, taking in a total of 4330 rupees. Let's just make the price of an analog watch X and a digital watch Y. Our first equation practically writes itself. 11x plus 6y equals 4330. On the second day, they sell 22 analog watches and 5 digital watches for 7330 rupees. That naturally gives us our second equation. 22x plus 5y equals 7330. By tracking the sales over 2 distinct days, we've created 2 distinct linear equations. If we multiply that first equation by 2, we can subtract and eliminate x, cleanly revealing that y, the digital watch, costs 190 rupees. Substituting that back in reveals that x, the analog watch, costs 290 rupees. The mathematics cuts right through all that confusion to reveal the exact prices for us. Section 4. Final mathematical takeaway. So the absolutely crucial point we need to remember is this. Mathematics is not just a subject to pass. It is a language that describes our reality. I want to end today's explainer by really challenging you. Where else are simultaneous equations hiding in your daily life? Look closely at your next family shopping trip when you're buying 2 different types of fruits. Or maybe try to balance a scheduling conflict where 2 different events share your limited time. You will absolutely find that these mathematical puzzles are all around you, just waiting to be solved. Thank you so much for learning with me today. Keep practicing those steps and keep looking for the math in your everyday world.